Good morning, everyone. Let us start with the concept today. That is there in the fourth module. Here it is, multi-threading concept. Um, so this threading concept you have studied already in OS, I guess. Okay. So what is actually thread? What are the different types of threads you have? So OS also you have studied, I guess. So I'll just go through few concepts on thread and what is actually the multi-thread programming in Java we will discuss today. Okay, hope you understood previous class concepts. So what was the previous concept which we have discussed? That is interfaces. Okay, interfaces it is like a class, but it is providing a full abstraction, indicating what? So it is having only method declaration and variable declarations, but it is not having a method which we have declared in a class for interface, so that body definition will not be available. So that is one thing which we are achieving, that is full abstraction with the interfaces. Okay. And in interface, we have studied that an interface can extend any number of interface, but a class cannot extend more than one class. So that is multiple inheritance is not allowed in Java. Okay, so multi-level is allowed, but that is achieved. Multiple inheritance is achieved through interface. Okay, so that is one advantage with Java, and unsupporting of multiple programming is not there in Java. So these are the concepts which we have discussed, and what are all the do's and don'ts with the interface also we have discussed. Okay, so let us discuss multi-threaded programming in Java. So what is actually the multi-threaded? Before going to the multi-threaded, what is actually the thread? Okay, so thread is a smallest unit or a set of instructions in a process or in a program. Okay, a single program is divided into multiple parts or multiple threads, and each thread is performing a specific task. Right? A process is divided into different parts. Process, you all know that. Hope you have studied in operating system. Process indicating what? Not only operating system, they are studying in C++, right? So process is a program under execution. We call it as a process. A single process is divided into multiple threads. A set of instructions. If I have taken an example of basic calculator. The basic calculator, which consists of five different operations, that are addition, multiplication, division, and the modulus, and one is subtraction. So right, and the main program. So that single program is divided into 6 different threads, and those 6 different threads run simultaneously. So that what we are achieving through multi-threaded programming is we are saving the CPU time. Okay, and we are efficiently executing multiple program in a within that time. So that is actually for that we need multi-threaded programming in Java. So Java supports multi-threaded programming. So this is one of the buzzword of Java, that Java supports multi-threaded programming. So here you can observe that single-threaded program, how it can be, right? So single-threaded program, here you can see that class ABC, so which is having some other operations and with a main. So this is a single program, so which begins the execution and the body of it, and what are the statements which we wanted to execute. So that is the body, and end or exit statement or a return statement, you could say. So this is single threaded program. I mean only one thread is taking place or one process will call, right? So this is multi-threaded programming. So here main thread or a single process is divided into different threads. So here you can observe that thread A, thread B, thread C. So we have divided a single process into different threads and named it as A, B, C. And here you can see that once you divided those threads, so you are going to call start method. You are going to call start method. So indicating what? They started executing. I mean threads are started executing. And threads are independent. Okay, they are not depending on any other. So if they are depending on any other thread, so what happens if any exceptions occur, other threads also may affect. So but here threads are independent, their execution is also independent. So if any exception occur in any other thread, so it will not be affect to the other thread. So that is one thing. And thread may use the result. So here you can observe that thread A and thread B. So there is a multi-direction symbol here. So thread A may make use of the result of thread B execution, or thread B in turn may make use of the result of thread A or data of thread A. They may switch or exchange the data or the result. So here in this case, if any exception occurs, here it is it will get affected. But on the whole, we will call it as threads are independent. Okay. This is actually the multi-threaded programming. So now let us discuss what is actually the thread. So here you can see that as I have said, thread is a piece of code that is run concurrently with the other thread. So as I said, the basic calculator program. So addition, subtraction, multiplication. So those are all the threads. Okay, single task. So that we are executing concurrently, or simultaneously or parallelly. So that is piece of code, a small code adding two numbers, multiplying the two numbers. So that is a piece of code or a particular task. And here thread is the lightweight smallest part of a process. So if in the exam or in the test, if they have asked any question like what is thread, you have to write it as thread is a lightweight smallest part of a process that can concurrently run with the other parts or other threads. Okay, so that the definition of a thread is this. Okay, or you can write a piece of code that run in a concurrent with other threads also. So either this or this you can write. Okay, and as I said, threads are independent because they all have a separate path of execution. Okay, they, as I said, the basic calculator program, we are adding two numbers and we are storing the result back in another variable. And similarly, in the multiplication, we are multiplying two numbers. So the path of execution of those threads is different. So no other thread will not get affected. Okay, so that is the conclusion is that what threads are independent. Okay, so the process of executing multiple threads simultaneously or parallelly, we will call it as multi-threading. Okay, so they may ask what is thread, or they may ask what is actually multi-threading. So you have to write this definition. Okay. Here. So as I already said that the main purpose of multi-threading is what? It will provide a parallel simultaneous execution of two or more parts of a program, and that uses the maximum utilizes of CPU time. I mean, it saves the CPU time. The threads are divided, and they say, for example, basic calculator program can take 5 seconds to execute. Okay, 5 seconds to execute. But once you have threads, five different threads, so they may execute within a 1 second also. Right, so that is utilization, maximum utilization of CPU time, and we are saving the CPU time. So that is the main aim of the multi-threading. Okay, so each such part of a program are called thread. That is what is a small piece of a code of a program or a process. We will call it as a thread. Okay. And this is very important, life cycle of a thread. So here, new thread. So if we are creating a thread, so main program or a process is divided into different threads. So here, one single thread you can consider, or we can consider new thread we are creating. So how we are going to call, or how we are going to start the execution of that thread. So here it's a life cycle and it is important and commonly asked question in the exam. So new thread. So why are thread class? We are creating a thread. So what is actually thread class? We will discuss in the next coming slides. So new is a state. So we are creating a thread for a process. And once you call a start method, so start is a compulsory method. So which is starts executing that thread. Okay, which begins the execution of that thread. So once it begins the execution of that thread, it is ready to run. It is not actually running. It is ready to run. So that is called runnable. Okay, it is ready to run. So once you called uh, run method, then only it will switch from runnable to running state. Runnable to running state. Once you call a start method for a thread, it is ready to run. Okay, it is ready to run. It will start executing the statements which it has, and it is in the runnable state. It is not actually the running state. Runnable state. Say for example, each statement is executing or compiling. You can say it's a runnable state. And once you call this run method, so it will be there in a running state. So start and the run method you should have to remember with the thread concept. Okay. So running state. So once it is in the running state, here it is in the running state. So it may successfully execute its execution are all the statements within this thread, and it may lead to a end of the execution. So that state we will call it as terminated state or the dead state. So here once the thread is completes its execution, we will call it as a dead state or the terminated state. Okay, dead state indicating that the thread is here created here and it is dead here. Okay, and here we will come back to the running state, right? So once it is in the running state, so when the sleep and wait concept may occur. So if it is in the running state, as I said in the earlier here in the diagram, thread B, it is running, but it wants some of the result of thread A, right? So in that case, what? So it should have to wait. What for what it should have to wait? It should have to wait for execution of the thread A. So after finishes of this thread A execution only, it will get the result of that thread A. So that it should have to wait, right? So in order to wait, so in the running state, so either it should have to call sleep or it should have to call a wait method. Okay, depending on the implementation, so sleep and the wait methods are getting called. Okay, so these are the built-in methods: start, run, sleep, and the wait. These are all not user-defined method. Okay, so they are already implementation is already available. So you just have to make use of it. The running state. So that will be there in a waiting state. So this waiting state is also called as a runnable state. Okay, so it is not actually waiting. So it is still waiting for the result, And once it got a result back from the other thread, so it may call a run method, and again it is in the running state. And once it is complete its execution, it is in the terminated or the dead state. So this is what the part of our life cycle. Okay, then if a thread is created, we have not called any start or a run method for that thread, so it may directly lead to a, or it may directly go to the terminated state or the dead state. Okay, so this is actually the life cycle of a thread. So this is the explanation of each state is here. You can just read it out. So before going to the multi-threading in detail, so let us just discuss about what is actually the multitasking, multi-threading, multiprocessing, and parallel processing. So we have already hope you have already studied in operating system that what is actually the multitasking and multiprocessing. Okay, the multitasking is what it is ability to execute more than one task at a same time is known as multitasking. Multi-threading is, so as I said, two or more threads executing simultaneously is called as a multi-threading. Multiprocessing. Multiprocessing indicating what? It is same as multitasking, but it is using, as the name is itself says that multiprocessing. It uses more than one CPU. Okay, more than one CPUs are involved here in the multi-processing. And parallel processing. Parallel processing indicating what? A single computer system will make use of different many CPUs. So that we will call it as parallel processing. Uh, this is just for your next is next how to create a thread in Java. Right, in life cycle we have I have said that using thread class you can create a here as I said. So using thread class you can create a thread. Right. So new is an operator which is going to allocate a memory for that thread which we are going to create. So thread is a class and this is a constructor. Right. So very first type of creating is here. Creating a thread in Java. So first type is what? Create a class that extends a thread class. A class is extending a thread class, then that class becomes a thread. Okay. And create a class that implements runnable interface. Right. So if you are creating a class that is implementing a runnable interface, then that class becomes a thread. Okay. Then so before we going into our programs, so just have a brief introduction about the methods which we are using in a thread class, not in a runnable interface, thread class. So that is first one is get name. Get name is a method. So these are all the built-in methods which are available with a thread class. So it is used for obtaining a thread's name. What actually the thread's name which we have given. So for example, class A if we have given, so A is a thread name. Get priority. Obtain a thread's priority. So you can our CPU can assign thread priority for a threads. Our user can also assign a thread priorities. So thread priorities that is also there in our next concept we will discuss. Is alive is a method. Next is alive is a method. So which determines if a thread is still running or it is still alive or not. And next is join method. So wait for a thread to terminate. Wait for a thread to terminate. Next run method. So here it's the entry point for a thread. So it is from runnable. So it is still waiting state. So from waiting to running state or runnable to running state should have to go. So for that run method. Sleep method. Uh, wait or a sleep method. So which suspends a thread for a period of time. Okay. So as I said in the life cycle of thread. Next start. It starts a thread by calling its run method. Okay. So here you need to remember run and the start. Okay. So these are also important. These are also important, but you have to remember mainly these two methods, that is run and the start method. Next, first program or a first method. The first method is what? Creating a class that is extending a thread class. So one is inheritance concept, another one is interface concept. Okay. Extend keyword where that extend keyword comes. So we get to know that it's a inheritance concept. So thread is a superclass. My thread is a subclass. So my thread is a thread which we are going to create. The class my thread, so user defined, you can give anything. Extends is a keyword and thread is a superclass. Right. So there is no need to write a thread class implementation here. So it is already available. So you can just make use of it. Okay. Class my thread extends thread, and within that you have to write a run method. So public void run. So public void run. So this is compulsory. Okay. So public void run, and within that, whatever you wanted, the statement you can include. Next, create a thread. Create a thread. So my thread is a class. You can create any number of threads using for my thread class. So thread 1 we are creating. You can create thread 2, thread 3, thread 4, any number of threads you can create for that class. Okay. So my thread 1, new my thread constructor which you are calling to allocate a memory for this thread 1. And via thread 1 we are starting the execution of that thread. So here thread 1 is in a new state. Once you call this start, so it will be in a runnable state, right? So once you call the start method, it will automatically call the run method. So there is no need to call this run method explicitly. So once you call this thread 1 dot start, so it will automatically call the run method. I mean, it is leading from runnable state to the running state. Okay, so this is important. This is just a syntax which I have given here. So this is just a syntax. RS, one more method to create and execute. So this is creating a thread and this is executing a thread. Okay, so create and execute. So new my thread dot start. New my thread dot start. So this single line is enough. So instead of these two lines, we can just have a single line. New my thread constructor dot start. So once you call this line or start method, so it will automatically call the run method. Okay, so this is the first method. And let us see an example for that. So here, class my thread extends a thread. So here, syntax which I have given, I am just appending few statements inside the body of the function run as well as in the main. Right. So in the run system.out.println, the thread is running statement which we have displaying here, and this is a separate thread class. And this is a separate class which is having a main method. So thread execution is a class. So the file name should be thread example 1.java, and public static void main. So within that we are creating a thread as I have given in the syntax. My thread t is equal to new my thread we are calling, and start method. Here you can see that we are not explicitly calling the run method. Once you call the start method, it will directly lead it to a run method. Okay. Yeah. So we don't have any implementation or a body for a start. You can observe here in the program. Okay. So start, which is just indication now, it's a starting of a thread and it is in the runnable state. So once you call the run method, so start method is automatically calling the run method, so which is going from runnable state to the running state. So it is saying for this program the output is the thread is running. Okay. The next method, threads by implementing runnable interface. I mean creating a thread by implementing the runnable interface. So that is create a class here, class my thread. So only difference is what in the earlier example, instead of implements we have extends, and instead of runnable we have thread. Okay, so here runnable is an interface which is already available with the Java package. Okay, class myThread, it is our own thread. I mean, it is user defined class name. Implements is a keyword. Runnable is an existing interface. So within that also, everything is same. Run method is there, and in order to create object for my thread, so my thread, my object, our thread one also you can use. New my thread, everything is same, but here an extra line is there. So even though if we are implementing a runnable interface, indirectly we are making use of thread class. Indirectly we are making use of thread class. Here, first we are going to create an object for this class, object for the existing thread, and next we are creating an object for a thread class. Object for a thread class. Thread1 is equal to new thread. So object which we have created for our class, user defined class, so that object you have to pass it for a thread constructor. This is the only difference, thread constructor. And via this thread1 we are going to call a start method. So this is one difference here. Even though we are implementing a runnable interface to create a thread, you have to explicitly call a thread constructor. For that thread constructor, you have to pass an object for our class. Our class is myThread. So thread1 dot start. So once you call the start method, so it will automatically call the run method. So what is that in a run method? It will just execute. So this is an example for second type or a second method. So everything is same. Only difference is what? Class myThread. Instead of implement extends, we have implements. Instead of thread, we have runnable interface and run method. And within that we have a statement. And we have another class which is having a main method. And here my thread, as I have told, my thread is our class. We are creating a object for that by calling a constructor, and thread is a class. We are creating an object for it also by calling a constructor, and that constructor is having a parameter of our class object. Okay, so here this object we are passing it to the thread class. So now thread is ready to execute. So instead of these two lines, you can create a thread in a single line also. Here, instead of creating object for our user defined class, you can create thread t directly thread class, new thread. So here, whatever the statements here, so we are just appending here. Okay. So new myThread. myThread is our user defined class name constructor. Right. Instead of passing an object name, we are just passing a constructor of our class. That's it. Okay. So via that thread, we are calling a start method. Start in turn call the run. What is that in run? This thread is running. So this is little tricky. You have to remember. Either that way or this way you can write. And this is an example which I wanted to show. So here, class multithreading demo, extends thread first method. So within the run, we have try and catch block. If there is any exception while creating a thread, it will catch that exception or not that exception. Next, in the class multithread, we have a main method. So what we are doing here, we are just creating the threads. So how many threads we are creating here? So we are creating the 9 threads. Okay. So here multithreading demo is our class name. We are creating an object for that. Via that object, we are calling the start method. So start method indirectly call the run method. So what is there in a run? Try block. So what is there in the thread block? System.out.println thread get name. So what is actually the name? We have our we don't have we have not given a name for a thread. Instead, we will give so get name. Via get name, we are fetching a name of that thread, and it is running. Thread, which thread is running, that we are going to display. So let us just see the output of this. So here you can see that thread 0 is running, thread 2, 1, 3, 4, 5, 6, 7, 8. Okay. So here there is no sequence here. 0, 1, 2, 3, 4, 5, 6, 7 like that. Okay, so we have 9 threads here. We are creating a 9 threads, and depending on the priority of the thread, it is going to run. So that is depending on the implementation or depending on the CPU. This is enough for today's class. Let's discuss second method program in the next class.